Heat loss in home. The primary mechanic is conduction. Heat traveling through materials. Okay? So I'm going to jump over here to my new little prop I have. And it's, I'm not unfurling the flag here, though it does seem like that. So we have, here's our wall. If you can imagine your wall at home, and I'll cut it open. Some of you may or may not have insulation in this pocket right here, or this, where the stud cavity is. We have cold outside and we have hot inside. Okay? This side, heat wants to constantly travel through this wall. All right? So that is conduction. Heat traveling through the materials. So if you can fill this cavity here as full of insulation as possible, as tightly as packed in there as tightly as possible, then you will slow the rate of loss through the wall. Okay, so same goes for the basement. It just flips it this way. You can imagine that this is cold underneath. Here's your concrete floor in the basement. If you can add insulation here, you're going to slow the rate of loss. Now, if you have an existing home, it's pretty difficult to dig up your basement and add insulation to the underside of it. So we're not going to go there. It can be done, but we're not going to go there this time. If we go up to the attic, we're going to flip it the other direction. We have hot down here, cold up here. We're going to stack up insulation here. Okay, we don't necessarily have a box here to fill. We're going to stack insulation here. Unless you have a sloped ceiling, then we're going to try and fill this cavity as tightly as possible with insulation. So conduction is the biggest loss of heat through our materials. The colder it gets outside, like this year, you know, we've struggled with keeping our warm inside because that cold has started to kind of creep into the materials. Those materials are starting to be cold. So that loss is, you know, going to happen quicker. And that's where we get concerned about that condensation issue. If we have this surface here cold, heat's traveling through, what's happening right here? Is it condensating? Where's that dew point? Conduction is like, you want to slow that rate of loss through the materials. Now obviously if you have an attic that looks like someone put all your insulation into a blender and threw it into the attic, it's not going to work too well. Okay? When I'm looking, this image up here may be new for some. This is a thermal image. I'm looking at this building through my thermal imaging camera. If I see this big dark purple square here, or rectangle in this instance, I got concerns that there's heat loss through there, so that's telling me that that material is cold, so there's no insulation at that specific point. I went up into the attic on this instance and discovered that the insulation had fallen away from the wall. So that's what I'm looking for when I'm coming in and looking at your home. Here we have a building, and you can see the heat loss around the, I don't have a pointer here, or do I? Oh, there we go. You can see this heat loss right here. No heat loss there. There's heat loss right there, and that's because this building had zero insulation in the cavities, none in the attic, zero insulation. So we're going to get that in there to slow that rate of loss down. Here you can see it's warm. I think this was the outside day was, I think it was right around 0. And you see here on the wall it's 30 degrees. That's on the outside of the building. That's not a good thing. You're paying to heat the outside of your building. You're paying to heat the inside of your building. You want to keep that heat inside.